All right, welcome to 2.4, solving equations with variables on both sides. Our essential question today, how do you solve equations with variables on both sides? We're going to be using a lot of the same principles that we've been working on, but this time we're just going to have variables on both sides. Our warm-up problem today, how many years will it take for populations of town A and B to be equal? And how do you know? Well, this one we see town A has less people, but they're growing at a faster rate. Likewise, they have a higher population, but they're growing a little bit slower. Okay, so there's going to be a point where they are both the same population, and our job is to find out when that happens to be. Okay, so really we can set this up in an equation because this town already has 3,255 people, right? And then they're going to add 100 people every year, right? So in 2 years, they'll have added 200 people. In 10 years, they'll have added 1,000 people, right? On this side, they start out with 3,300 people, and then they add 75 people every year. Okay, so in 2 years, they'll have 150 more, etc. Okay, and then we're trying to find out at what point are the populations going to be equal. Okay, so we can just put an equal sign right here. We're trying to find out when is this going to be the same as this. Okay, and this is what we're going to be working on today. We have the variable on both sides here, right? So what I like to do is I like to get all the variables on one side. Now, do you move the 100y over here, or do you move the 75 over here? I'm going to move the 75 over because it's the smaller number in this case. I'm subtracting 75y from this side. I'm also going to subtract it from this side, 75y. Now, why did I do that? I just want to avoid negatives. It doesn't really matter, but the more you do these, the more you realize that there are ways to make things easier, I guess. Okay, so 100 minus 75 will get you 25y. And then over here, we crossed out the 75y, so all we're left with is 3,300. Okay, now we're trying to get everything away from the y. We want all the y's on one side, we want all the numbers on the other side. And so our first step in doing that is that we're going to get rid of the 3255. We subtract it, it turns into nothingness, poof, abracadabra. Okay, we're left with 25y on that side. And we need to do the same thing over here, 3255. And we are left with, let's see, that subtracted would be 45. You can use a calculator for that. Okay, so we're left with 45. And now we're multiplying, and we want to get the y by itself. That's our end goal, right? Okay, so we need to divide both sides by 25. Okay, and so 45 divided by 25, grab your handy dandy calculator, 45 divided by 25 gets you 1.8. So the question, going back to the question, how many years will it take for the populations to be equal? It will take 1.8 years for them to be equal. All right, so our next problem here is a break-even problem. You see the words break even here. You'll use these all the time in your life, whether it's Netflix, whether it's a gym, whether it's rent, whether it's a credit card, whether it's a car loan. I've used these several times in my life. You want to find out when does it just not matter, and at what point is one option better than the other. All right, so Laurel pays somebody $35 to clear her driveway when it snows, and she wants to buy an electric snowblower for $689 so that she can just do it herself. And if the area that she lives in has an average of 5.2 snowfalls each season, how many seasons is it going to take in order for her to break even on the snowblower? So basically, at what point will she have spent the same amount on the snowblower or on somebody doing her driveway for her, and she's paying $689 either way. Okay, so that's what we want to find out. And then after that amount, then it's going to be cheaper for her to just have the snowblower, because then she won't have to pay any more money past the $689 she's already spent, right? But before that, then it would be cheaper to pay somebody to do it. Okay, so if you were only planning on living in Minnesota for, say, 5 years, you'd want to find out, is it cheaper for me to buy a snowblower right away, or is it cheaper for me to just pay somebody for 5 years, for example. Okay, so first off, she pays somebody $35 to clear her driveway every time it snows. Okay, and there's 5.2 snowfalls each season. Okay, so how much is that per year that she's spending? $35 per snowfall, and then 5.2 snowfalls a year. That, let's get our calculators out, is $182 per season. I'm just going to put per season. Okay, so $182 per season that she is spending on getting her driveway cleared. Okay, or she could just spend $689 on a snowblower. We're trying to figure out how many years is it going to take for her to get up to $689. So $182 per season times however many, I'm going to put years because I don't like S as a variable. It looks too much like a 5. Okay. So how many years is it going to take her in order to get to $689? And at that point, then it doesn't matter either way. Okay, this is multiplication, so we're going to divide by 182. Okay, and so again, calculators, unless you want to challenge yourself with some awful mental math. 689 divided by 182. Hopefully you got 3 point, let's round to the tenths, so we'll go 3.8. So it's going to take her 3.8 years in order for the snowblower to kind of pay itself off, right? So if she's only staying in Minnesota for 3 years, then it doesn't really make sense for her to buy a snowblower. Okay, but if she's staying in Minnesota for 4 years, then the snowblower option is going to be cheaper because she'll end up spending more than $689 to have somebody else do it. All right, so the next problem for us, we have 5s plus 13 equals 2s plus 22. Like in that first problem with the town people, okay, I always like to move the variable first, and I like to move the smaller variable over to the other side. So here we have 5s and 2s, so I would subtract 2s just because I don't like negative variables. It's another step. Okay, if you end up bringing the 5 over, it doesn't matter. You're going to end up with a negative 3s, and you'll just have to deal with the negative later. It's fine, but I prefer to do it this way. And so 3s over here plus 13. Over here we canceled out the s's, and so all we're left with is 22. Okay, now our goal is to get s by itself, so we need to start getting rid of the junk. So we're gonna, sorry, I'll show my work here. Okay, we're gonna subtract 13. And 22 minus 13 is 9. And over here we're left with 3s. And we divide by 3. And we get s equals 3. Okay, the next one, now we have some parentheses. Yes, I love parentheses. In the last lesson we talked about there are times where you can just divide the two. In this situation, you still can. I'm going to suggest this would be a situation, there's just a lot going on. It's not a nice, easy problem. If there's a lot going on, I would just distribute. It's going to lead you astray less than the other method. So let's go ahead and distribute. We're going to get 6x, and then 2 times 1 is 2. Over here we do 4 times x, and that gets us 4x. And we also do 4 times negative 5, and that gets us negative 20. All right, and now we can bring our variables over. 4 is less than 6, so I'm going to bring that over. And so we're left with over here 6 minus 4 is 2x plus 2. And all we have left over here is negative 20. All right, remember we got to start getting the junk off of this side, so we get 2x, we're going to subtract 2, right? Now careful here, because most people will say 18. Wrong. Negative 20 minus 2 is going to actually get you negative 22. Here we're going 2 more in the negative direction, and then we divide by 2, and we end up with x equals negative 11. Don't forget about your negative sign. All right. Now we have some vocab identity. The identity is when basically it's the same on both sides of the equal sign. So for example, if you get something like this, x plus 1 equals x plus 1, that's an identity. It's the same on the same exact thing on both sides. It doesn't matter what number you plug in here; it's going to work. Any number will work. On the flip side, usually, if you solve this, you bring your x over. It's going to cancel out. You end up with 1 equals 1. Okay, if you end up with like 1 equals 1 or 7 equals 7 or something like that, that's identity. No solution would be like x minus 3 equals x plus 2. Okay, and when you bring your x over, all of a sudden you get negative 3 equals 2, and you're like, wait a second, that's not right. That would be a no solution. A null set is what I learned it as. And no number will work. It just doesn't work. There's no solution. Okay, so what is the solution to the equation? This one right here. Well, first off, we have t plus 8 equals. Now over here we can combine some like terms, right? Oh, I gotta kind of hustle up because I only have 2 more minutes left. We're gonna combine like terms, so we have negative x plus, or negative t plus 2t. And this gets us t, and then plus 6. Okay, now when we bring our t over, we end up with 8 equals 6, and we know that that can't be true, and so it's a null set. There's no solution. Okay, last one here. What is the solution of the equation? Oh, we got 2 equations here. Okay, first step is parentheses. Okay, so we're going to do 3x plus 5 equals 3x plus 15, and then we still have our minus 10 sitting out here. Okay, now we combine like terms. 3x plus 5 equals, if we combine the numbers together, oh, I'm sorry, that's 10 still, so we get 3x. 15 minus 10 is 5. And already I can see it's the same on both sides, right? So we have the identity. Identity. All the real numbers will work. That stands for real numbers. Any number you plug into that formula or into that equation will work. Okay, last one here. See if I can squeeze it in 1 minute. Again, we're going to distribute. So we get 3x. 3 times 4 is 12 minus 10. Okay, 2x minus 5 equals 3x. Now we combine like terms. 12 minus 10 is 2. Okay, now I'm going to bring the 2x over here. So we get negative 5 equals x plus 2. Subtract the 2. And I get x equals negative 5 minus negative 2 is negative 7. Whew, I finished with 15 seconds to spare. Here is your practice problems. Remember to show your work, please.